Hello and welcome back to another Python video. So in one of the previous videos we worked on this function called condition, and what that did was took in a 2D array which had a bunch of data read from whatever sensors. So say you have an orange and you have a grape and you have a dog, and then you also have we have an orange again, so these are fruits, a grape, and then a cat. Then obviously the orange and grape appear lots of times together, whereas dog and cat are just sort of there and they're random sensors which they're not really important. And this condition statement will return what's supposed to be. So let's just recap and run that in Python 3. So we're going to call this A, and then we can down here do condition and A. And then we'll gather that. We'll just use random variable names. There we go. And run. And here we go, orange and grape, it's associated from the original array. So now I've recapped on that. Let's just get rid of that. We're going to head over to Circuit Python. Now, as you've seen, I'm using mu instead of my usual idle, which I do videos in. And that's because we're going to be working with Circuit Python, and mu is set up for that. Now, Circuit Python is a microcontroller which you can upload Python onto, but we'll get more to the wiring and the circuit board later. But right now, we're going to start writing some code. So with Circuit Python and the conditioning, we want to test out it learning about different sensors. Now we could make a weather system and leave outside to measure the temperatures and when things should be watered, and then it will eventually learn how it should water. But when we don't really have the sensors for that at the moment, so we're just going to set up a very simple LED and button press to remember what LEDs it should turn on with different buttons. So for starters, we're going to import what we want. So import time, we're going to import board, and we're going to import also we're going to from digital IO. And what I love about this IDE is the finish of it just comes up with the words you're typing, and I like that because it saves a lot of time, and also it leaves less error for spelling or anything like that. So firstly, we're going to create an LED. So LED equals digital in out, and let's do it on pin 5. Just checking my board and what I've soldered in. Yep, so pin 5. Does that have to be capital? No, it needs to be a D because it's digital pin 5. So this is pin 5. Ooh, not pint. Right, and then we want to do led.direction, and we want it to be direction dot and output, because it's an output. We're outputting to the LED to be on, and when you talk to the LED, it's going to be a true or false. True to be on, and that will send power to it and turn it on, and false if if it's not on. So now we want to create a bunch of buttons. So these are going to be our inputs, and we're going to use them and put them into an array, and it's going to find, so it's going to be an array of button 1, button 2, and button 3. And basically what it will do is, and there'll be like multiple ones, and it's going to have its state, so true, false, or whatever. And then it's going to associate these in the condition and find, well, button 1 and button 2 are always true together. So that means that I should always put on the these LEDs. So let's create some buttons. So B1 equals, and we're going to do the same what we did for the other one. We're going to do board dot, and we're going to do digital pin. We're going to do 6. Let's do 6. And button 2 equals digital in out board dot, and we want to do pin 9. So I am using the Feather M0 Express, and I will have pin 5, pin 6, and pin 5, pin 6, pin 9, and pin 10. So 5, 6, 9, oh, that shouldn't be a capital, and button 3 equals, once again, digital in out, board, and that was going to be 10, I said, wasn't it? So this is our inputs. Then what we could also do is create a bunch of LEDs. We won't worry about that for now. We just want to look at buttons. Down here, we're going to get input from these buttons. So while true, we're just going to keep going through, and down here, time.sleep and 0.01. This is just to debounce the delay. And up here, we're going to do if. This is going to be button 1 dot, and what we're going to do is get the value going to be true or false. So right now this is going to be if the button's off. So we're going to do led dot value equals false, and then here we're going to do else, and it's going to do print button press, and do led.value equals true. So here it's going to loop through and it's going to basically take in input from one of the buttons we've defined and output to the LED if it's pressed or if it's not. So let's wire this up. What we're going to do, we're going to get our buttons, so let's just put them across here. And another one here. Ooh, there we go. So we will want to connect these all to the ground. And if we get some resistors, so let's get some resistors in here. So we want these going to each of the sort of pins of the buttons. So this means that there will be a supply of electricity going through. So let's wire this up. So we wanted one pin at pin 6. Then we wanted the next pin. So we use a better wire. Here we want that going to pin 10, and then we have a final. I'll try and use another long one. We have a final pin for this button here. So 1, 2, 3. Then we're going to wire up the ground to the ground. There we go. And we have an LED. So we want the ground on the ground and the rest going to pin 5. What I didn't do was it's a rookie mistake. B1 dot, and we want to do direction because we haven't yet told it what the what it's doing. So direction dot, and it's an input, and then we'll just do this for everything. So we'll go down here and change this not, because that's not needed. So if there's still an issue, and that's because we need to do b1 dot, and we're going to do pull, and it's going to be pull dot, oh no, what have I done, dot up, and we're going to do this for all of them. So 2, 3, there we go. So oh, there's, so nothing's happening, then I press it and it goes a bit mad. There was actually nothing wrong with the code apart from the delay. So here's 1 and I press it and it comes up. I have to hold it down. So here is 0.5 and I'll just upload that. Hold on, let me drag this up. Then I press it and it's a lot more, well, it's mostly instant. I have to press it a bit. Then I do 0.1, get plotter up, and then button pressed, and it's a bit more instant. If I hold it down, it goes on. So as you can see, that the code is uploading. But we want to take this further than just press button. So what we're going to do, we're going to create a little thing called data, and this is going to be an object. So we're going to create this object using just a normal object-oriented method, self, and then we're going to have a size. So basically what data is going to be is it's going to be an array, a 2D array, which just takes in lots of data, but what we don't want to do is just while true and just keep adding loads of data to an array. We want it to remain at a specific size. Self.size equals size. Then we'll do self.array equals, and it's got nothing in. So we're going to add and items. So what this is going to do, it's going to do if length of array is going to do greater than self.size. So this means that we've got too many items. We're going to delete. So delete, and we'll do one of this should be self.array. We're going to do self.array here again, and item 0. So it's going to delete the oldest item which was added in, and below it's going to do array dot append, and it's going to add the items. So def show, this is going to return self, and this is just going to return self.array. So here we go. So this is going to be a data structure, just a queue of data, and if it gets too big, it just removes the oldest item entered. And let's create this. So we're going to have array, we'll call it array, why not, equals data, and we'll have size 10. So it's going to take in 10 different inputs. This is going to be the newest inputs. So we're going to do array dot append, dot add, and we're going to just add b1 dot value, b2 dot value, and b3 dot value. There we go. And if we print array dot show every time, so how many? Oh, I've done 0.1. We'll do every second. I'm just gonna print. So what's happening here? Oh yeah, there's an error. Data object no attribute append. Right. That's because self.array.append. I keep forgetting that. There we go. So we've got true, true, true. Let's just firstly print each iteration. So let's have a look. True, true, true. And then I press the first button and it's false. I press the second button and it's false. And I press the third button and it's false. And all the buttons are false if I press down. And then I just start taking different fingers off. And yeah, so you get the picture. What we want to do next is do something with this data, find associations. So print will condition, and this is going to be array dot show. So this is going to output in fact we don't need any of this now, it's a bit useless. So let's have a look. Don't need to put the filter up. So it's true. So it's finding that true is the general consensus. But now if I hold down false, it's going to find, there we go, now it's learning it's false. and it's learning the values, although we don't have any unique values here. So let's convert these all to string. So we're going to have false, false, and false, and then we're going to do b1 plus and the string of the value, and then we'll do that. So now we'll upload that. So b1 true, b1 2, and then we'll have I've started pressing false. So you see that what happens in the array now is it's learned that b2 and b3 are always true, whereas b4 changes because I'm pressing false. Although I'm holding down false, just then you see it comes up as all of them significant, and it's found, well, actually in all my data, because remember it replaces every 10 times, so it refreshes itself to find that, oh look, b1 is false and b2 is true and b3 is true, because that's all it's ever known. But then I press b2, now that's changed to false, and then it knows that b1 being false and b3 being true is significant. So as you can see, it's taking real world data and it's converting it to find what's relevant. Now, yeah, I'm just pressing buttons. What can you use that for? Well, what happens is you could replace these, and as I said at the beginning, how you could use a weather monitoring system or sign which waters the garden. Instead of a button, I could have a temperature sensor, and instead of a second button, I could have a water sensor, and then I could have a time sensor, so it just tells me what the time is, and go by hour, because obviously minutes is going to be difficult to time the right minute, and that's just a lot of inconsistencies. And then every time I water my plant, it will sense there's moisture, and it will sense what the temperature is and what the time is. And it might find that the temperature is completely irrelevant, but the moisture, there's always water when I press button, when the time is 12. So I water it every day at 12, and it finds that significant. And then what you can do, as you see up here, I added an LED. You can wire things up, or wire actuators up. So you might have your own water supply system, and it says that every time it receives information about there's water in the plant, that links or correlates to the actual output of watering the plant. So then you could have a little motor and a pump which takes water from a bottle nearby and puts it into the soil. And you've trained it that every time at 12 o'clock you will water the soil, and it will know when it gets to 12 o'clock it should water the soil itself. So that's the theory of it, and I hope to do more videos taking this theory and making little robots and showing you more what you can do with this. So I hope you enjoyed, and thank you for watching.